All right, so let's get started with this worksheet. Nitrogen compounds के ऊपर है. Give the molecular formula of noradrenaline. Okay, molecular formula simply means you add everything up. So how many carbons, how many hydrogens, सब कुछ आप add कर दोगे. So I have 6 here and 7 and 8 carbons. Hydrogen मेरे पास होंगे 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 2 more, 11, N and O3. ठीक है, तो ये मेरे पास molecular formula आ गया. State whether or not noradrenaline shows stereoisomerism. So do we have any chiral carbon? Let's see. Do you see any chiral carbon? है ना? This carbon is chiral. So because of that, yes, there's a chiral carbon present. Clear? बहुत simple सा question था ये. Nitrous acid reacts with this at 5 degrees Celsius. ठीक है, with separate samples of noradrenaline and phenylamine. The reaction with phenylamine produces a stable diazonium ion. Coupling reaction हो रहा है. ठीक है. Suggest why the diazonium ion is produced with phenylamine is stable. क्यों stable होगा? Phenylamine क्या होता है? यहाँ पे जब diazonium ion बनेगा, so why is this going to be stable? Obviously it will not stay as it is. Obviously ये ट्रिपल बॉन्ड टूटेगी और नाइट्रोजन आगे फिर फर्दर रिएक्ट करेगा, बट ये यहाँ पर स्टेबल क्यों है? It is stable because the ring stabilizes the positive charge. Okay, the positive charge is stabilized by the it is delocalized, yeah, it is by the ring that you have. So by delocalization in the ring. Okay, when one of this molecule reacts with one HNO2 molecule, okay, the products are one water molecule and one molecule of unreactive gas. Unreactive gas to फिर nitrogen होगी, and one molecule of organic compound made of carbon, hydrogen, oxygen only. अच्छा, तो basically हो क्या रहा है? वो इसको हाइड्रोक्साइड यहाँ पे NH2 की जगह पे आ जाएगा. OH माइनस यहाँ पे सब्स्टिट्यूट करेगा. So you're going to get water, you're going to get nitrogen, you're going to get OH here, this one. So everything else stays as it is. OH, 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 and OH. Okay. 2-naphthol can show similar properties to phenol. ठीक है. Phenol, it is used to produce Sudan 1 and orange colored dye stuff. Okay, ठीक है. On the diagram above, circle the bond that makes this substance a dye stuff. Obviously, it is the diazonium bridge. ठीक है, so it is this one. So मैं इसको circle करता हूँ. Describe how Sudan 1 can be made using phenylamine and 2-naphthol as the organic starting material. अच्छा, तो पहले तो हमें phenylamine से नाइट्रस एसिड के साथ रिएक्ट करना है. ठीक है, ताकि हमारे पास ये डायजोनियम ब्रिज बने. ठीक है, और सॉरी ताकि हाँ ठीक है, नाइट्रस एसिड से रिएक्ट करना है और टेम्परेचर हमारा कोल्ड होना चाहिए. हाई टेम्परेचर पे वो ब्रेक डाउन कर जाता है. तो हमारे पास डायजोनियम आयन बन जाएगा. वो डायजोनियम आयन जो है वो फिर नेफ्थोल के साथ रिएक्ट करके ब्रिज बना लेगा. तो वी विल स्टार्ट विद द phenylamine reacts with nitrous acid at temperature less than 5 degrees Celsius भी कर सकते हो, 10 degrees Celsius भी कर सकते हो. ठीक है, at cold temperature बोल दो, 10 बोल देते हैं चले, या 5 भी बोल सकते हो. ठीक है, to form the diazonium ion. ठीक है, and which reacts with 2-naphthol, but has to be in hydroxide situation. So 2-naphthol in alkaline solution. So important बातें सारी मैंने इसमें बता दी आपको. Alkaline होना चाहिए for this reaction to occur, क्योंकि OH आता है. और फिर डाइजोनियम ब्रिज बनाने के लिए हमें नाइट्रस एसिड चाहिए जो फिनाइलेमाइन के साथ रिएक्ट करेगा एट कोल्ड टेम्परेचर। हाई टेम्परेचर पे डाइजोनियम ब्रेक डाउन कर जाता है, तो इस वजह से दिस इज हाउ यू गेट। क्लियर?
Yes, sir.
Calcium nitride reacts readily with water to form a white precipitate suspended in an alkaline solution. Okay. वाटर के साथ रिएक्ट कर रहा है तो मतलब हाइड्रोक्साइड और हाइड्रोजन है. The oxidation number of nitrogen does not change during the reaction. यहाँ पे नाइट्रोजन के पास +3 है तो उसमें भी 3 रहता है अगर, तो अमोनिया लग रहा है मुझे. Constructing going for this reaction, ठीक है, Ca3N2 plus H2O. Water will provide H and OH, so OH will form calcium hydroxide जो कि suspended precipitate है, and ammonia will be made. ठीक है, बैलेंस करना होगा इसको. Okay, done. Clear? आसान था. Okay, if this is moles, I'm gonna skip this. Compare and explain the basicity of ammonia, ethylamine, and phenylamine. Again, you just have to compare them in terms of which one has a lone pair which is free to react and which one has a lone pair which is not. या कोई lone pair ऐसा हो जो inductive effect की वजह से ज़्यादा available हो गया हो. So for example, in the case of ammonia, you have just the lone pair available like this. In the case of ethylamine, you have the lone pair stabilized, or there's a positive inductive effect from this ethyl. So this is going to be more reactive. And in the case of phenylamine, inductive effect, in fact, the lone pair is going to be delocalized into the ring. So इसकी वजह से जो phenylamine है वो सबसे बुरी base होगा, इनमें से weakest base होगा. So we'll say that ethylamine, you'll explain it, that ethylamine has a positive inductive effect from the ethyl group, making it the most basic. So ethylamine has positive inductive effect from alkyl group, making it most basic. And then we have ammonia. Okay. अमोनिया के बारे में हमें कुछ भी बताने की जरूरत नहीं है. We will now focus on the phenylamine part, that the lone pair is delocalized into the benzene ring, और उसकी वजह से it is the weakest of these. So that's all you have to talk about. 2,3-dimethyl-phenylamine can be prepared from 1,2-dimethyl-benzene in 2 steps. ठीक है, सबसे पहले उसने नाइट्रो ग्रुप यहाँ पे अटैक करवाया उसका, तो सब्स्टिट्यूशन हुई है, इलेक्ट्रोफिलिक सब्स्टिट्यूशन, एंड देन उसने उसको रिड्यूस करके एमाइन ग्रुप बना दिया. ठीक है, राइट एन इक्वेशन टू शो हाउ H2SO4 जनरेट्स द इलेक्ट्रोफाइल ड्यूरिंग स्टेप 1. स्टेप 1 में हमें नाइट्रो ग्रुप चाहिए. ठीक है, तो H2SO4 क्या करता है कि नाइट्रिक एसिड को ब्रेक डाउन करता है. इट रिएक्ट्स विद नाइट्रिक एसिड, H2SO4 provides us with the HSO4 minus nitro group and 1 water molecule. ठीक है. Draw the mechanism of the reaction between this electrophile, the nitro, and the reaction. ठीक है, so सबसे पहले हम नाइट्रो ग्रुप बना लेते हैं. इस पे पॉजिटिव चार्ज है और इस पॉजिटिव चार्ज की वजह से इस पर अटैक होगा. ठीक है, जैसे ही अटैक होगा तो उसकी वजह से इस पे रिंग जो है वो ब्रेक डाउन हो जाएगा. ठीक है, तो हमारे पास ये चीज होगी, बट इसमें रिंग पूरा नहीं रहेगा, पॉजिटिव रहेगा. ये मिथाइल ग्रुप ऐसे कैसे ही रहेंगे, और यहाँ पर we'll have hydrogen and nitro. Now this hydrogen will obviously donate the bond electrons here, और हमारे पास यहाँ पर H positive separate मिल जाएगा हमें. ठीक है, so that's the mechanism. Mechanism को याद करने का बड़ा एक आसान सा तरीका है. This nitro is going to displace the hydrogen, right? So इसने अपना positive charge hydrogen को देना, लेकिन directly नहीं दे सकता. तो पहले वो रिंग को देगा और रिंग से पॉजिटिव चार्ज हाइड्रोजन को मिलेगा. सो नाइट्रो से रिंग, रिंग से हाइड्रोजन. That's how the positive charge travels, and that is how we can easily remember the mechanism. अगर याद करना हो तो. The drug, whatever the name is an excess of 2-chlorobenzoic acid. ठीक है, बनवा रहा है वो इस reaction में. Okay. Deduce the molecular formula of this acid. So you just have to count all the atoms. ठीक है, और उसके बाद उसको अपने so carbon 6 carbon here, 6 carbon here, 12, 13, 14, 15. So C15. और हाइड्रोजन कितने हैं? 1 2 3 4 5 6 7 and 8 and 6 14 and 1 15. N भी है, O भी है, N तो एक ही है, oxygen 2 है, and there you go. Name the function group apart from benzene ring in methanic acid. This one is amine and this one is carboxylic acid. So we'll say amine and carboxylic acid. Make sure you name both of them. कोई एक नहीं बताना, उसने groups बोला. ठीक है? Okay. The structure of nicotinamide is shown. ठीक है? State the number of delocalized electrons in nicotinamide molecule. कितने electrons होंगे? Delocalized electrons. Electrons from the carbon atom, 2 electrons in the pi cloud from the C00, and 2 from the lone pair of nitrogen. So carbon atom say 1 2 3 4 5, or 2 from this one, 2 from that one. Oh, 6-membered ring है, तो 6 plus 2 plus 2 10. ठीक है. Predict the H&H bond angle in the NH2 group. H&H bond angle
104.
120, because H, the nitrogen here, it has 3 bonds, right? And if its lone pair is delocalized into the ring, so then it has just those 3. It's not tetrahedral anymore. It's planar. Nicotinamide can be synthesized from nicotinic acid. Okay. The synthesis involves 2 steps. ठीक है. क्या हो रहा है यहाँ पे? Draw the structure formula of E in the box. So OH is being displaced with the NH2. ठीक है. So क्या होगा? I need ammonia. That ammonia will bring in NH2.
Acyl chloride, like OCl. OH
I'm
is
just
going
thinking.
to be replaced by
We
Cl.
can't directly displace OH, yeah. So we can't directly displace it. So I need, I could get HCl, right? And that HCl will react with it. Yeah, you're right. Acyl chloride is made. And now I can displace the Cl with NH2. I could not have directly displaced OH. Okay. So yeah, that's right. So I could have brought in an HCl to do this. And now we'll bring in ammonia to do this. Give the name or formula of a suitable reagent for step 2 ammonia. Nicotinamide reacts separately with aqueous acid and aqueous alkali. Okay, the 6 member. Okay, so in presence of HCl, what's gonna happen? This is going to displace NH2, is it? No, wait, over here it will displace it. So this is going to form
Salt of amine.
no, wait, this won't just be salt. Yeah, you're right. This will be OH and then COOH will be made. And that COOH will then react with NaOH and make O minus and Na plus. Okay, it won't be a salt of amine. It will be NH2 displaced with OH, and then that OH makes this a carboxylic acid, which will then react with sodium hydroxide. Okay, so that is one thing that we'll get. The other thing that we'll have on this side will be, I'm unsure about this one.
Won't it be like C double bond OH?
Why?
This is hydrolysis of amide, right?
Oh, this is amide. Yes, you're right. I
Yeah,
did
this
not
is amide.
yeah, this is amide. Yes. I was just focusing on the amine part. So you're right. It is hydrolysis of amide. So we'll get carboxylic acid back. Yes. Thank you. Okay, nicotinamide can be reduced to compound X. Okay, identify a suitable reagent. Nicotinamide has the C double bond O part, and that has somehow been the oxygen is taken away, replaced by two hydrogen. What is that process? When you remove oxygen and you add hydrogen, what is that process called? Reduction. You're taking away an oxygen, you're adding in two hydrogens, so that is reduction. And we need a strong reducing agent. So we could take lithium tetrahydroaluminate in ether. Okay. Peter explained the basicity of NH2 group in phenylamine, nicotinamide, and compound X. Compound X, yeah. Okay, so compound X has lone pair with the inductive effect from this. Okay. And wait a minute, even if there's no inductive effect, one thing to remember here is that the lone pair here is very far from the ring. So it
It
won't
cannot be
go into
localized.
this. Yeah. And in phenylamine, we do have the ring taking that in. And nicotinamide, which was that? This one. Nicotinamide, over here, the CO will have its electrons donated into this. Okay. Which will pull the nitrogen's lone pairs further back. So the amide group is going to donate its electrons into the ring, as we saw earlier as well when we counted them. So clearly nicotinamide has more electrons delocalized. So nitrogen will be unable to like use them to do the basic functions. So I think this one is more basic because lone pair is available. This one's just two electrons are being donated here. And in nicotinamide, 4 electrons are being donated. No,
So
2 electrons are
phenylamine
being.
is
So phenylamine is a weaker base than
middle.
this.
Yeah.
And nicotinamide is a weaker base than this phenylamine. So I think the order will be X as the most basic. This has less and the nicotinamide even less. Clear? Does that make sense? Compound K is used as a starting material for synthesis of gallic acid. Okay. All right, so यहाँ पे क्या कर रहा है वो? सबसे पहले he is added the nitro group here. So that is electrophilic substitution. And of course, he's creating a nitro using that. Okay, construct an equation for the formation of that. So H2SO4 plus nitric acid makes nitro group plus HSO4 minus plus water. Okay. Uh, Next one. Again, the same thing. Sure, another nitro added. Okay. Complete the mechanism and draw the intermediate step. So that's again easy. The ring attacks this hydrogen. The ring breaks down, obviously. So this is positive. Everything else remains the same. And then this donates its electrons, and you're able to get that thing. State the name of the mechanism in C2. Because they've asked us for the name of the mechanism, we'll tell the full thing. We will not just say substitution, it's electrophilic substitution. Okay. So we'll mention the whole thing. Okay, compound M. Yeah.
So If they were asking us about the type of reaction, were we gonna write nitration?
We could have just said substitute.
Okay.
Yeah. Okay, state the reagents and condition for step 4. What is step 4? They have they have taken the NO2 and they converted it to amine group. How do you do that?
SN plus HCl, right?
Yes, exactly. Good. So 10 and HCl. P reacts with an excess of sodium nitrite and dilute. ठीक है, is diazonium बनेगा. I think diazonium बनेगा. Let's see. Compound Q is then converted into gallic acid. नहीं, diazonium पता नहीं बना.
Yeah, I think it may be diazonium salt.
Let's see. So what's going to happen? First of all the NH2 are eventually converted to alcohol. And this is breaking down. This is gone, replaced with OH.
I think it will be
This will
diazonium.
definitely be diazonium. Yes.
Yeah. It
Because
can
of
be
these
predicted
conditions.
from the
So
formula as
diazonium.
well.
Yeah, from this one, I can predict that. So I think this is where all the diazonium bridges are going to be. So I'll just add those. So the diazonium will be N with positive charge, 2N with positive charge. And then they will bond with the negative charge available, which is of chloride. So this, and this. So you can just combine it all together and you can just say that that is N2Cl. You can say that. ठीक है? And यहाँ पे it will be COOC2H5. Okay. So as a structure of compound Q, ठीक है, वो हो गया. In the next step, they are going to reduce it and you're going to get OH. Sorry, they're going to hydrolyze this. So you're going to get HCl, then OH and all of that. The molecular formula of this is again pretty straightforward. हमने ये question 2-3 दफा देख लिया है. And yeah, main concepts we've gone over. It's the basicity of amine and amide and phenylamine. That's the comparison usually. It's about the amide, how does that react, and the reactions of amide, hydrolysis and reduction, all of that. The third main question is usually about the diazonium bridge, so coupling reaction. Okay, all right. Thank you. Take care.